Everyone, welcome back to Chapter 2 Thermochemistry SK025. In this video, we are going to talk about Chapter 2.2 Calorimeter. So, by the end of the lesson, you should be able to define heat capacity and specific heat capacity, calculate the heat change in a constant volume calorimeter, which is also known as the bond calorimeter, and calculate the heat change in constant pressure calorimeter or the simple calorimeter. So first of all, heat capacity. You have a symbol capital letter C. So this heat capacity is defined as the amount of heat which is represented by this small letter Q required to raise the temperature of a given quantity of a substance by either 1 Kelvin or 1 degree Celsius. So both units of temperature is accepted. So the unit of this heat capacity, we have joule per Kelvin or joule per degree Celsius. So the amount of heat required to raise a given amount of substance by 1 Kelvin, or the amount of heat required to raise the temperature by 1 degree Celsius for a given quantity. So this given quantity, it means that any quantity. It can be in 1 gram, 100 gram, 50 gram, 0.25 gram, and etc. So for this heat capacity, we have a formula C equals to Q over delta T. So this is your amount of heat, and this is the difference in temperature. Also, we can try to rearrange your equation so that you get Q equals to C delta T. Alright, so for the Q is heat, which we have the unit of joule because heat is the same as the energy, so the unit will be the same as energy. So delta T refer to change in temperature. So with a unit Kelvin or degree Celsius. Next one, we have specific heat capacity, represent using symbol small letter c. So for this specific heat capacity, it refers to the amount of heat required to raise the temperature of 1 gram of a substance by 1 Kelvin or 1 degree Celsius. So this specific heat capacity is only refers to 1 gram. So the units will be in joule per gram per Kelvin or joule per gram per degree Celsius. So the energy required or the heat required to raise 1 gram of substance by 1 Kelvin, the heat required to raise 1 gram of substance by 1 degree Celsius. So the formula, this will be your small letter c, small letter c equals to Q over M delta T. We can also rearrange your equation so the heat equals to mc delta T. So for this C is a small letter c, okay, specific heat capacity. So if you want to look at the units for the heat Q, you have a unit joule. For the mass, you have the unit gram. For the temperature, either is in Kelvin or degree Celsius. Alright, and therefore you have the unit joule per gram per units of temperature. For this Q equals to mc delta T. So M in this case means the mass of the substance. So for example, the specific capacity water is constant. So it equals to 4.18 joule per gram per degree Celsius. So if let's say you have 50 gram of water, then you need to use 50 times with 4.18 times with the difference in temperature to get the heat change. Alright, so next thing we want to look into is the type of calorimeter. We have two types. One of it is bond calorimeter, and in which this bond calorimeter happens at constant volume. For this bond calorimeter, the uses is mainly to calculate the heat change for a combustion reactions. And the other type of calorimeter is the so-called simple calorimeter, or sometimes we refer as the simple calorimeter as the coffee cup calorimeter, in which it happens at constant pressure. So for this simple calorimeter, the uses is mainly to use for calculations of the heat change for a neutralization reaction, or the reactions involve aqueous solutions as their reactants and product. For example, you react two salt solutions to produce another two salt solutions. Okay, so it involves aqueous solution as their reaction. So next, we want to know how to identify a suitable formula to solve the calculations related to a calorimeter. So from the questions, you need to identify what is the reactions. Is it combustions, neutralizations, or just simply a reactions involving aqueous solution? And you need to also identify which of the following terms here absorb heat energy. So the clue is given in the questions. So you need to make sure you identify, is there any information related to calorimeter, for example, or is there any information related to the water? Okay, so if let's say you have the informations for water, or you have the mass of waters given for this specific heat capacity of water is a constant 4.18 joule per gram per degree Celsius, and you have got your differences in temperature delta T, therefore we'll choose this formula. All right. And if you have the information for solution, so this one normally will be in the questions related to neutralizations reactions or the reactions involving aqueous solutions. So MC delta T, mass of the solution, specific heat capacity of the solution, which is also the same as the water, and the difference in temperature delta T. If let's say you have the informations of calorimeter, or we want to find the informations of this, therefore you would going to choose this Q cal, okay, where in which this capital letter C stands for our heat capacity of the calorimeter. Okay, so C delta T. Bear in mind that there is 2 points that I want you to highlight inside your handout, which is this Q reactions, or just simply the Q. So just now we mentioned that this refers to the amount of heat. Okay, or in other words, we can say that this Q is either the heat release or the heat absorbed or the heat change for any quantity of substance. Any quantity, it can be 0.5 mole, 1 mole, or 1.5 mole, any quantity. So the units of this Q can be either in joule or kilojoule. Okay, joule or kilojoule. And if you have this delta H, okay, delta H, it refers to the heat change, heat release, heat absorbed for 1 mole of your substance. So, madam, give you an example. For example, we want to find enthalpy of combustions. So, when 1 mole of substance is completely combusted in oxygen, so enthalpy refers to 1 mole of your substance. So, the units will be in joule per mole or kilojoule per mole. Okay, this per mole refers to 1 mole of substance. So please take note, Q and delta H, they both means the heat energy, the heat change. But what is the quantity? This one is what you need to take notes. So let's go into our first scenario. If let's say a metal is heated and immersed into a simple calorimeter at room temperature, immersed means it put into or it transferred into a calorimeter. So we assume that calorimeter does not absorb heat. Therefore, heat release from this metal, okay, will be absorbed by the water. Okay, if you look at this diagram, let's say this one is my metal, and I heat it until 100 degrees Celsius. And this is my water at room temperature, say I have 25 degrees Celsius. So when I put this metal into my 25 degrees Celsius water, says the final temperature reach until 60. So this one will be your final temperature. Okay, so the heat is transferred from the metal into the water. So in this case, you need to identify your formula. So Q metal, Q water, and for the heat absorbed by water, we have MC delta T. For this abbreviation, W refers to the water. Okay, so mass of the water, specific heat capacity of water, which is fixed, 4.18 joule per gram per degree Celsius. And then you have this delta T. Now, if let's say the delta T given is in Kelvin, therefore this specific capacity will be in per Kelvin. So this is a first scenario. There's no reactions for this scenario. We are just transferring the heat only. Okay, assume no heat is lost to the surrounding. Okay, all the heat is transferred into the water. All right, so let's go into our second scenario for our combustion reactions. So if the questions mentions that a substance X is combusted and the heat is absorbed by both calorimeter and water. That means the questions give you some of the informations of calorimeter, or they want to find something about calorimeter, and they give you the informations of water. So mass or volume of water is given. Therefore, you know that heat is released by combustion reactions, and the heat absorbed by both calorimeter and water. So there's information for calorimeter, there's information for water. Then this one will be your formula. Okay, the heat released from combustions equals to the heat absorbed by calorimeter and water. So for calorimeter, if the heat capacity is given, or they ask you to find this, then it will be C delta T. For the water, if mass is given, then it will be MC delta T. But if the combustion reaction in the questions, it only mentions that heat is absorbed by calorimeter. That means no information of mass or volume is given. So there is some corrections. No mass or no volume of water is given. That means all the heat is only absorbed by the calorimeter itself. Therefore, in this case, the heat released from these reactions will be absorbed by calorimeter only. So the formula go this way. Okay, the heat released by combustion absorbed by the calorimeter. So for Q calorimeter equals to C delta T. So this is a capital letter C, heat capacity. All right, for the third scenario, it's either for a neutralization reactions, or the reactions happen between two salt solutions to produce another aqueous solution. So reactions between acid and base, neutralizations, release heat, and the heat is absorbed by both calorimeter and the solutions produced. Okay, so this is the case for the questions that if both of the informations for calorimeter and solution is given. Okay, in this case, we will focus on the calorimeter. So if the information's calorimeter is given, that we will include it inside the formula. Solution is a mass inside your neutralizations or reactions involving aqueous solution. Okay, why does it say so? If you refer to this diagrams over here, if let's say we take acid and base neutralizations reactions, say if we have 50 milliliter of the base and we have 50 milliliter of the acid solution. So when this acid react with the base, you are creating your salt together with water. Okay, so this one make your salt solution. So when there is a reactions happen between two aqueous solutions, that means your total volume will be the total sum between the acid and the base, which is 100 milliliter. So that means the heat release from the reactions neutralization will be absorbed definitely by the solutions itself. And if the questions give you informations related to calorimeter, or you want to find something about calorimeter, therefore your equation, okay, your formula will increase both informations for calorimeter and the solution. So we're using calorimeter is C delta T, solution MC delta T. I'm using abbreviations S or SOL to represent solution. Okay, so for the solutions, as it's contain water, so for this specific heat capacity of solutions, we will take the specific heat capacity same as water, 4.18 joule per gram per degree Celsius. And then you have your delta T. All right, so take notes over here. Mass of solutions equals to the total mass of acid plus base. Or similarly, volume of the solutions equals to the total volume of acid and base. We will take into account the density equals to 1 gram per milliliter. For the same scenario, for the reactions neutralizations or reactions involving aqueous solutions, if let's say the questions doesn't mention anything about calorimeter, so that means for this reactions, the heat is released from the reactions, which will only be absorbed by the solutions produced. okay, will be absorbed by the solutions produced. Therefore, your formula will only depend on the Q solution, the heat change in the solution. So M S CS delta T.